Okay, so we're studying two curves in this example. They give us 2 to the x and log base 2 of x. In other words, these are pretty closely related curves. This is an exponential of base 2, and this is a logarithm of base 2, and you can see how their curves are almost mirror images. They look like the stitching on a baseball or something. They curve away in opposite directions. And they give us the tables of values for them, and something interesting happens with those too. Minus 3, 1/8. 1/8 minus 3. Minus 2, 1/4. 1/4 minus 2. 1, 2, 2, 1. 3, 8, 8, 3. 4, 16, 16, 4. These tables of values are also mirror images of each other, and we've seen that kind of behavior before, haven't we? That's the kind of thing. Actually, before I tell you, where have we seen that kind of behavior before, where one function contains like 416 and the other one contains 16, 4? Do you remember how that happens? This is what we see with inverse functions. Anytime you have an inverse, you'll have, if you give him 4, he'll give you back 16. Give his inverse 16, and he'll give you back the original 4. These two functions do exact opposite things to pairs of numbers. So they point out that one of these curves contains 3, 8, and the other one contains 8, 3. We've said that already. Now, what else do they want us to do here? What statement can be made from the point minus 2, 1/4 on the graph of y equals 2 to the x? Well, this is an x value, and this is a y value. So if you plug them into the formula, they're telling you that y, 1/4, is 2 to the minus 2. And that is true. This is saying if you take 2, flip it over to 1/2, and then square it, you'll get 1/4, and that is indeed the case. So all of the numbers in that 2 to the x table of values up here can be written like this, where this number is 2 to a given power. And for the logarithm, that works as well. If you have 16, 4, that's an x value, that's a y value. You can plug both of those into this equation, and it gets you y equals log base 2 of x. So the base 2 logarithm of 16 is 4. And that's true as well. What this is saying is, pretend you don't know the 4 for a minute. Log base 2 of 16 is saying 2 to the what will make 16. And if you count on your fingers, 2 times 2 is 4, times 2 is 8, times 2 is 16. That was 4 multiplications, so this is indeed 4. So they're showing you how these pairs of numbers connect to what the function does, and how you can turn a pair like this into a mathematical statement. This is a logand, it's the number inside a logarithm, and this 4 is the power that's required to get you there. If you had, say, 32, 5, that would be saying if you want to get all the way up to 32, you'll have to do 2 to the 5th power. If you have 1, 0, that's saying if you only want 1, then you'd need 2 to the 0th power, and so on. So complete the table below. The answers to all of these things are in the table of values above. I urge you at this point to pause the video and try to fill this out on your own if you haven't already, because I'm going to smash through it right now and it's going to go kind of fast. Okay, here it goes. Log base 2 of 4 says 2 to the what equals 4. This means 2 to the what equals 2, and this means 2 to the what equals 1. If you write these in exponential form, the base is always the 2 here. So this one started out as 2 to the 3 makes 8. You go in kind of a roundabout like this, 2 to the 3 makes 8. This one would be 2 to the 2 makes 4. They're writing it 4 equals 2 to the 2, but I think it reads a little nicer this way. 2 to the 1 makes 2. Not big news, but it's nice that the formula can tell us that. And 2 to the 0, that looks like a heart, but it's supposed to be a 0, makes 1. And now doing some smaller numbers, 2 to the minus 3 makes 1/8. Right? Because 2 to the minus 3 means take 2. flip it, which gets you 1/2, then put it to the third power. So 1/2 times 1/2 times 1/2 does indeed give you 1/8. This one, going back to log form, would be log base 2 of 1/4 equals -2. So this number, which was our base in exponential form, is still our base in logarithmic form, and the other two numbers trade places. The quarter says, okay, I'm tired of being alone, I'm going to be on the crowded side. The -2 says, I'm tired of being on the crowded side, I'm going to go be alone this time. And similar thing here, we still have base 2. The half says, okay, I'm going to go to the crowded side now. And the -1 says, okay, I'll go to the lonely side. Sorry, this half isn't exactly an exponent. It should be more like here. It's the logand. It's the log base 2 of 1/2. So the base always stays in the same place, and the other two numbers trade sides. That's the way I used to remember it. And you should be able to look at these expressions afterwards and say, this means, like here, 2 to the 2 makes 4. And on this side, this is saying 2 to what power would make 1/4? The answer is -2. So the exponential and logarithmic form are saying the same thing, just in coming at it from different directions.